I want to see some answers. Who can get close to 24 for question A? Or who can get 24 for question A? I'll wait for your answers in the chat.
While they do that, sir, I just saw in the chat now, Mosa asked if there'll be classes next week. Yes, there will be classes. There'll also be classes on the following week, but just not on the 21st, as the 21st is a public holiday. Am I correct in saying that, sir?
Yeah, so there's a 21st is a public holiday, so there won't be. But yeah, otherwise the show goes on. I'm seeing the answer come through. Kayelichle. This is not a 9, this is a 6, because there is a bar at the bottom. So you have to go, I'll give you a hint though, start with 5 plus 6, and you'll get pretty close to the answer. And 9 times 2 plus 5 plus 1, Charity's got an answer coming in. And Rebetswe's got an answer coming in. Oh, I think there's more than one way of doing this. So the one that I've seen, I think someone else got it above 2, but Charity, 6 plus 5 is 11, plus 1, all of those together give you 12, and then you just double the 12 to give you 24. And then the other one that I could see, oh, that was for the next one, that's for B. Okay, so who was the first person to get that? I think it was 9 times 2. Yeah, this isn't a 9 in the first one. So I think, Charity, the star goes to you for your outstanding work in question A. What about question B? Can we get to 24 with question B? Rebetswe's got an answer. Esther's got an answer. So 9. Okay, this is, first of all, this isn't a 9, it's a 6 because the line is underneath where the thing is. But we're moving from A and we're moving on to B. So here we have 6, 6, 8, and 5. And someone has said 6 times 6 is 36. And then if I take away 8, then I get 28. And then if I take away 5, I get 23. So Rebetswe, your answer isn't quite correct, but you're very close. Who can get me to 24? You can do it. 9 plus 5 is 14. 8. There's no 9 here, unfortunately. Yes. Oh, and if there are any new students, are there any new students joining us tonight? If you are, give us a thumbs up in the chat. We just want to see how many of you are joining us for the first time. We're just doing our warm-up at the moment. And yeah, Miss Anya is the other math teacher who's helping me today, or helping me. And she is in the chat stream and she will give you a nice welcome. Has anybody managed to get this thing before we start the lesson? So I was thinking, what about 8 minus 5 is 3? Can we get the answer from there? If I go 8 minus 5 is 3, and I've got these 2 6s that are left, how can I get to 24? Oh, welcome to Leah. Welcome to Injiri. I hope I'm saying that right. It's great to have you with us. And don't worry, we'll explain as we go. But we start the lesson always with a bit of a warm-up. And so I'm just waiting for students to help me get to 24 using these 2 remaining 6s. So we've got to 3. Okay, so these are both 6s because the line is underneath the curly part. There is no, Charity says 8 minus 5 is 3. 3 times 6, okay, let's see. So 3 times 6 is 18. Oh, yes. And then 18 plus 6 is 24. And so we've used all numbers once, and we've used only subtraction, addition, and so on. Mosa says 6 times 4. Mosa, I would just say, how did you get the 4? Novo says 8 minus 5 equals 3. Okay, 3 times. If we do this, that would give us 36. because 6 plus 6 brackets get done first, and 12 times 3 is 36. Okay, let's start the lesson, but well done to everybody for participating nicely in the Maths 24. And I can see each time we do this, we're getting stronger and stronger. So I want to start by just handing over for some admin announcements to Miss Anya. Miss Anya, if you could take over for a second and just explain to the students any admin announcements that are coming through.
Okay, so hi everyone, my name is Anya, or Miss A or Miss V. So I'm just going to close this curtain a bit. I hope you guys can see me. It's a bit dark on this side. Anyway, so I'm also a maths teacher. For those that are new, I'm going to help serve the lessons. So with regards to admin, so Watobe is going to run a holiday program. You'll get more information on it closer to the time, but it's going to start on the week of, let me just grab my calendar very quickly, on the week of the 28th. Yes, thank you, sir. The 28th of March. And I think that Monday is a public holiday, but I was, no. Yes, it is. I'm not too sure.
21st but holiday. Yeah.
Okay, sorry. Apologies for that. But there'll be lessons and it's included in your fees. So you're all welcome to join on that. It's not additional payment or so. And then just please stay on at the end of this lesson. For those that are new, every Wednesday we do a fun quiz. I'll post the link to the quiz in the chat as well, but you basically access it from the Watobe site. So where you would go to enter the class, it's basically where you say join class. Beneath it is a button that says start quiz. It's basically that link. So I'll share it in the chat as well. And then once you're on the quiz, you're welcome to hop off. And that's all from me. Back to you, sir.
Okay, yeah. So basically, at the end of the lesson, when I say like sort of goodbye and you go off to do the quiz, you don't have to come back. That's how we end the lesson. And that's important for the newbies amongst us, because obviously you're getting used to the feel of the structure of the lesson. Okay, let's start the lesson. So in the last lesson, what we were doing, we started to talk about the topic of fractions. Okay, and fractions are really just pieces of a whole, but there are different ways of representing fractions. And the main ones that we spoke about are what we call common fractions, or we also spoke about improper, but the main parts, the main three fractions that I think about are common fractions, decimals, and percentages. Now, there are other bits and pieces. So there are what we call improper fractions and also mixed numbers. But really, these three categories are the ones that we need to get the most familiar with. And most of today will still be just focusing around this top branch of common fractions, improper, and mixed numbers. I will be adding in some decimals and percentages as we go, but that will be more of a focus in the next lesson. Now, what we need to make sure we know how to do is, just like anything, when dealing with fractions, we need to make sure we can plus and minus, and we also need to make sure we can times and divide. So the lesson today will start with a bit more on plus and minus, and then in the second part is going to focus on timesing and dividing. And there's some basic rules that we need to make sure we always know about when dealing with fractions. So I'm just going to go over the one really important one to start with. And the one we spoke about in the last lesson was you can only add two fractions if they have the same denominator, right? So if we have 3/4 and we want to add it to 5/6, as that question stands, the problem is that they don't have the same denominator, or what we said is the family name. And the only way we get around that problem is we create a set of equivalent fractions so that have the same denominator. And so what we always think about first is, what is the denominator on my equivalent fraction? And so I want to ask in the chat, for the number 4 and the number 6, what is the denominator going to be for my equivalent fractions? So both of these things are going to be written as equivalent fractions, but I need to know what denominator am I going to use that's going to help me put this 4 and 6 together.
So
yes.
Sorry, may I jump in here? Because there's also, when we do these, some
Yeah.
students might think that 2 is also a common denominator. And may I help the students with a quick trick so they never get wrong when
Go
finding the
ahead.
common? So when you find looking for common denominator, you're basically looking for genes that both legs can fit into. In other words, both numbers. You can never buy smaller genes. Okay, you're not going to jump from a closet to get into the genes. Okay,
Yeah.
you can only buy the same size or bigger genes. So that's the only thing I want to say, because some students might have felt, because I see the answers in the chat, but some
Yes.
students might have said 2, and remember 4 cannot fit into 2. Okay, that's just
I
a
love
few
that.
sizes
I
too
love that.
small. All right, back to you, sir.
Yeah. So, that's such a good way of saying it, because when you're looking for common denominators, everybody, you can in theory wear something bigger if you put a belt on, or whatever, but you can't get into something smaller. And so a good way of thinking it is the number needs to be at least as big as the biggest number or bigger. Now in the chat, I see most people got that the denominator was 12, right? So the lowest common multiple of 4 and 6, or the number that both 4 and 6 go into, is 12. And in order to get that, what we need to do is we create an equivalent fraction. And so we multiply, then we ask ourselves, what did we need to do to get 4 to 12? We times it by 3. But if that's all we did, we've changed the fraction. The only way it stays the same fraction overall is if we multiply the top by 3 as well. In that case, we get 9 over 12 as the equivalent fraction. Now for the second one, we have to do something similar but not the same. I'm going to multiply by 2 to get to 12. And so I multiply by 2 here as well. And so here I get 10 over 12. And so now, if I look at this now, my denominators are the same, they have the same family. My final answer will be 19 over 12, because I can use that these fractions are the same. Now, if I want to convert that from an improper to a, we know that 12 goes into 19 once with 7 left over, and then the denominator will stay the same. So that is really important. Now, some of you may have chosen, instead of going for 12, you may have chosen to go for 24. Because you may have said, I'm going to times 4 by 6. Now, that's not wrong, but all it's going to have to happen in that case is, instead of multiplying by 3 here, you would have multiplied by 6. And over here, you would have multiplied by 4 to get 24. And so you would have got 18 over 24 plus 20 over 24. The final answer would have been the same, but essentially that's what you're going to do. Now we really need to make sure we've got this idea of a common denominator. Now it works for plus and minus. So we're going to start the lesson with just a little recap of the last lesson. And I want you to do these. Okay, I'm going to tick some of them. You are going to do that one for me. You are going to do that one for me. You are going to do that one. And let's see how you do. So you're going to do A, B, and C. And once you've done those, once you've added those fractions, you're going to put your answer in the chat. And I just want to see how much of the last lesson you can remember. And if we've got this waxed, we'll move on to the other operations. So over to you guys. It's now 12 minutes past 5. We will go until 5:15 on this question, just doing A, B, and C. And then Ms. Anya, is there anything I need to be aware of before students get going?
I'll just check now. So with regards to the example you did with if students have gone with the denominator root being 24, in other words, they go for a larger denominator, that's totally fine. Just means you're going to buy extra large clothes. And when you buy extra large clothes, you have to buy an extra large shirt. So everything's going to be very big, but once you simplify it, you're going to have the exact same answer. And then just another thing, Mosa in the chat, she's not very much with us. So I think I'm somehow going to answer on her behalf, if you don't mind, sir. Yeah. Mosa, just try for me number A, please. Just try your best. Use the knowledge that you have. And then when Sir goes through these, I think Sir just goes slowly through number A, step by step, what we do. Yeah. Okay.
So I think it's a good point you raised, Ms. Anya, is that if you can get your denominators to be as small as possible, that will help you, because the bigger size clothes you buy, the more and more difficult it gets to deal with. So it's not a problem to be a little bit over, but if you go way over what you can do, it gets unnecessarily difficult to kind of walk around in them. And so I would encourage you that while you could in the first one go 12 times 6 is 72, that wouldn't be a good idea, because there may be a number which is smaller than that. And ask yourself, what does 12 and 6 both go into? If you go back to the first lesson of the year, what is the lowest common multiple of 12 and 6? You know, if you had to write them out, you'd go 6, oh, a pen. So, you know, you'd go 6, 12, 18, 24, and then 12 goes 12, 24, 36. Are there any numbers that are in common on both those counts? That's the hint I'm going to give you. And then while you do that, some water. Okay, let's have a look in the chat. All right, see, Tebogo has got answers coming through. Mike has got some answers. I haven't done them yet, so I don't know what the answer is. But Kayla's got an answer coming through. Yeah, it's good. There's some interesting... Miss Anya's giving some very good feedback, Mosa, so don't be afraid to have a look at the chat.
How can you get the answer?
Yeah. So, first of all, here's my hint. I'm going to tell you that, for A, I'm going to suggest that the common denominator that we need is 12, because if you look, 6 goes into 12, and so if I could make the second fraction out of 12, then it's going to be very easy to add them together. So all I'm going to do for A is I'm going to multiply the bottom by 2, and then I'm going to multiply the top by 2. And what I'm going to get then is I'm going to get 10 over 12 for this one. And then this one, I'm not going to change at all because it was already out of 12. And so if I add those together, I get, make sure, 15 over 12. If we wrote that as a, if I wrote that as a mixed number, it would be 1 and 3 over 12, or you could write it as 1 and 1/4. That would be the most simplified, oh, excuse me.
So
that would be the most simplified. Yes.
I think I'm just checking here in the chat as well, and thank you for that as well. See, Mosa, and I'm sure others are still just a little bit lost. The big thing is when you change your denominators, so now you got bigger genes, right? Whatever you do at the bottom, you need to do at the top as well. Otherwise, you're not working with an equivalent fraction. So what I see a lot of students are doing is they will say, right, so they got their common denominator as 12, which is correct. You got the first step correct. But then they still say, right, 5 plus 5, which is 10. But remember, that 5 over 6, because you changed the 6, now you must change the 5 as well, because it works like a scale. What you do on one side, you have to do on the other side. That's all from my side.
No, I just want to quickly show you what an equivalent fraction is. So most of us know what a half is. Now, if I times the top and bottom by 2 of a half, so let's say I do that, is that still the same fraction? Well, then I'm going to have 2 over 4. And we know that 2 over 4 is exactly the same as a half. But I'd say what, let's times the top and bottom by 3 now. So if I times 2 by 3 and 4 by 3, I get 6 over 12. Is 6 over 12 still a half? Yes. So this is the key idea that I'm using in this question. And you have to take some time to just think, do I really understand what an equivalent fraction is? An equivalent fraction is when you times the top and bottom by some number and you get a new looking thing, but it's still the same fraction underneath. If I wanted to simplify 6 over 12, I would divide 6 by 6, I get 1, divide 12 by 6, and I get 2. So that's going to be in the background the whole time. So let's see if I can use that in question B. So in question B, my initial focus is around this 24 and 8. I think that 8 goes into 24. And so if I could just work with this, fraction here, the whole question will be done. But how do I get 8 to 24? And this is where knowing your times tables does actually help. So I'm going to times this by 3. But if I stop at that stage, then I've changed the fraction. It's no longer equivalent. I have to multiply by 3 as well there. And then if I think about it, I haven't changed the first fraction, no need to. But the second one, I now have 21 over 24. The good news is that the denominators are now magically the same. Well, not magically, I made them the same through my choice. So I add them together and I get 34 over 24, which if I want to, that's an improper fraction. And then I would ask myself, how many times does 24 go into 34? It goes once with 10 left over. And so both of those answers would be correct. This would be considered the most simplified, but both of them would be correct. And nothing would be wrong with that answer there. So that is the answer for B. And then let's look at C. C is a little bit trickier because 25 and 20 are getting bigger numbers. And so I need to think, what do both of these go into? If I times them together, it's going to be huge. So what I could do is I could just count them out: 25, 50, 75, 100, then 20, 40, 60, 80. The first number that they both go into is going to be 100. And so I'm going to try and make the denominators 100 in my equivalent fractions. So what do I need to times 25 by to get to 100? Times it by 4. I must do the same on the top and bottom. For 20, I times by 5. So what does that give me? 4 times 14, 40. I get 56 over 100. 5 times 7 is 35. 5 times 20, so I get that. And then if I add them together, 56 plus 35, 86, 91 over 100. And so that would be my final answer. And just as a bonus, from the last lesson, 91 over 100 is the same as 91%. Okay, Ms. Anya, is there anything from the students are?
I find that the students are battling a bit, sir.
Okay.
Like I said previously, like they might get the denominator right, but then they still go back. And like, for instance, for C, some of them got the denominator as 100, but then they say, right, 14 plus 7. So I do think a lot of students are struggling a bit. So I do think we need to go a bit slower through these.
Okay, guys, we're going to slow down a little bit, and we are going to focus on doing 2 more of these. So on the screen right now, you will see, I'm going to call this one D and this one E, and I'm going to give you a bit more time.
Oh, sorry, sir.
Yeah.
Sorry to interrupt you, sir. I just checked now. Someone, thank you to Belichle. So at number C, you had your denominator as 100, but just check, so it's a minus sum. And we added.
Flip, you're quite right.
Thank you to Belichle, and you as well, Ria Betswe.
So 56 over 100, there shouldn't be a plus, there should be a minus there.
Yes.
Which changes the question. Guys, well done.
Oh, so 21 is actually in fact right.
So now we get 21 over 100.
Sorry, guys.
There we go. So well done to everyone who spotted that. It is in fact 21 out of 100. Okay, now let us move to D and E, and I'm going to zoom in so that everybody gets their full attention onto this question. And I want you to try and get the answer for this, because there's no point. We really need to make sure that we get this structure right. If we get this right, it'll mean a lot for the future. And I just want to emphasize the ideas again. Step 1, look at the 2 denominators. They are not the same. If they are not the same, you cannot add them. If you look at E, same thing. These denominators are being these fractions are being subtracted, but the denominators are not the same. Your only job in life is to first find a number that both 4 and 16 go into. Once you found that, you want to rewrite these fractions as equivalent fractions using that number that they both go into, because that will allow you to add them. Now, I'm not going to say more. I'm going to rather give you time to think. And we'll watch the chat, and Ms. Anya will also respond in the chat. Sita Bocho has got an answer. Atlechang has got an answer. Keep those answers coming through, guys. I want to see them in the chat. What number do both 4 and 16 go into? If I'm really stuck, I could write them out. Uh-huh. I think they both go into 16. So how do I do this step now? So to get 4 to 16, I multiply it by 4. But then I must do the same thing with the top, which gives me 12 over 16. And this one, I don't need to change anything, so it's 7. Twelve plus 7 is 19. And then yep, I see that there are definitely people who are agreeing with me. There are a few little mistakes that are happening. So notice, guys, how I don't do anything to the second fraction because it already has 16 as its denominator. I only had to create an equivalent fraction for the first one. The second one, I just rewrote it over here. And then I said, well, they're both going to have the same 16 denominator. So that's going to be the same here, but I just added my numerators. Now, what about E? I'll wait a bit more time. I see 1, so 7 over 21. There's a couple of different answers coming through. I think that the key with this question is going to be realizing that the denominator involved is going to be 21. There we go. So if I think 27 goes into 21, and so I want everyone to think about that as you go. What do I times 7 by to get to 21? I think my times tables, here we need to know our times tables. I times it by 3. And so I'm going to get 15 over 21 minus 8 over 21. And then I know that I end up with 21. What's 15 minus 8? It's 7. Absolutely, guys. But if you want to be even more sneaky correct, does 7 go into 21? Well, 7 goes into 21 3 times. And so you could say that this fraction is the same as 1 over 3. And so that would be the most simplified, because essentially you could go 7 divided by 7 is 1, 21 divided by 7 is 3. And if you want to, I see there's a chat about this. 1/3 can also be written as a percentage. All fractions can be written in all 3 of those forms, but it just sometimes we choose the one that is easiest. Portia, I agree with you completely. Well done on getting that right. Well done to Harry, Mbali, to Belichle. We are doing well. I just want to, before we have our brain break, could you just give me a thumbs up if you're feeling good about this, and a thumbs down if you're not feeling quite so good about this section? I just want to get a feel for the class. But I feel like after the initial part, we're getting there. So I think I'm going to zoom out and okay, we'll talk about that bit in a moment.
So
yes.
you don't have to do it now, but I do think it would be quite nice just to have a time for a little Q&A a bit later on also. I do see there's a few hands that pop up every now and again.
Okay, cool, no problem. Okay, guys, I tell you what, let's just stand for a second. So I'm going to ask you to have a little brain break, because we've been doing a good job, but I know that with the stuff, it needs to really sink in. And in order for it to sink in, your brain needs time to digest it. So let's take a little brain break. And so just stand up. And hopefully you can see me. And then I'll take some questions now when we get started. Oh, can you see me? So what I want you to do, guys, we did this once upon a time. Then we find table out the way. So what we're going to do is we're going to take our right hand and we're going to put it on our nose. And then you're going to take your left hand and put it on your right ear. So you're going to feel a bit wound up. Now you're going to take your left hand and it's going to go from your ear to your nose. And then the other thing is going to go to the opposite ear. Okay. And now I want you to see, can you switch back? And can you switch back again? I can see some of you are getting this. You've been practicing. And then if you're really good, can you switch as fast as me? Wah! Oh, it's tiring. My brain hurts. But I'm told my sister is a learning support teacher, and I'm told that's called a midline crossing.
Yeah.
And apparently your brain has to learn to do that in order to do a whole bunch of things earlier in our education. But
yeah,
you also, it's so good, it forces all your energy to go to one place, that your brain gets to relax from maths for a second. And it's very good for students to just, and I need to find a few more. So I don't know if anybody else has some cool brain breaks. You are most welcome to join us and take center stage. I will give you the floor in future. Okay, so there are quite a few students who need a little bit more help on the common denominator. I'm gonna, what I encourage you to do is I'm gonna start on the multiplication, but I'm gonna, whilst I'm setting multiplication tasks, I will respond to questions still about common denominators. But let me just start on the idea of multiplying fractions, because multiplying fractions is actually easier than dividing or than adding and subtracting. So let me just give one example to start with. If I have a fraction like this, a quarter, and I want to multiply it by a third. Okay, so you can visualize that if we were doing the good old pi days, that would be a quarter times, I suppose a third would look kind of like that. So that would be what it would be visually represented. Now, it's a little bit weird to think visually about how you multiply two pieces of a whole together. I mean, multiplication is really just repeated addition, but luckily there's a very simple algorithm that we can use for multiplying. And basically it goes like this. If you imagine 3 times 2, 3 times 2 is the same as 3/1 times 2/1. And what do we do when we multiply two fractions like that? All we do with fractions is we multiply the top with the top. So 3 times 2 is 6, and 1 times 1 is 1. And so we get 6. No surprise, because we all know 3 times 2 is 6. So all we do with multiplication is that, for example, a quarter times a third, the top times the top, or the numerator times the numerator, is 1, and 4 times 3 is 12. And so the final answer is 1/12. And so that's the main idea. Now, sometimes what happens later on is you may also get a situation like this, where you get 2 1/3 times 4. Now, that's a bit trickier because it's not clear like what exactly to do here. And so all I need to do initially is I need to change this mixed number into an improper fraction. And then the 4 needs to be written as a fraction, which is just 4/1. So essentially 2 1/3, what would that be written? How do I get an improper fraction? Well, I take and I say, look, 2, if the denominator is 3, that's essentially going to be 2 lots of 3, or 6/3. And there's already a 1 there. So if I converted that to an improper fraction, I would get 7/3.
Sorry, sir.
Yeah.
While we're on that, because I know a lot of students struggling, if you struggle to go from a mixed number to an improper way, what you can also do is take the whole number, which is 2, times with the bottom, add at the top. So that's how I did. You go like you work in a circle. You go times with the bottom, add with the top. So I think that's also the easy way to remember it for our students.
Yeah. So take this big 2 here, multiply it by 3, which gives you 6. Add it to the 1 on top is 7. Then you get 7/3 as the equivalent fraction. And then what I want to do is I want to say, well, what about this 4 over here? How do we multiply? Do we multiply by the top or the bottom? Well, 4 can be written as 4/1, because anything over 1 is still itself. So now we have it in the form that we're used to, where we can multiply as a fraction. And so what we'll get is 7 times 4 is 28. And then 3 times 1 is 3. And that is an improper. And then we ask ourselves, actually, for now, I'm just going to leave it like that. But we can change it back into a mixed number if we like. But I think we need a bit more practice. So just to get grooving, just to get on the run, 2/3 of 24, if you see the word of, it just means multiply. So 2/3 of 24 means 2/3 times 24. I want everyone to try and complete these 4 questions and then put your answers in the chat. Okay, put your answers in the chat and just see how you can do with the multiplying of fractions. Now, while we do that, for students who are feeling a little bit confused about the last section, I would love to answer your questions. So please do put your question in the chat. Maybe give me an example of a question in the chat.
Yeah.
And you can always write it like in the chat. If you want me to answer this question, write like 1/2 minus 2/3.
Oh, so sorry to interrupt, sir. Can you just zoom in a bit on the 4 questions, sir? Sorry to interrupt you there.
How's that?
That's just a bit more down.
Okay.
Bit more. There we go. That's fine.
Okay, cool. So okay, so Tumelo, are you talking about multiplication or are you talking about addition and subtraction?
So I'm talking about the 2/3 of 24. So how do you do it?
All right. So the big problem with 2/3 of 24 is just that when you're multiplying, you don't know if you go to the top or the bottom with 24. And so the trick is to write 24 as 24/1, because 24/1 is the same as 24, but it takes away the confusion as to what we're multiplying. So now you know 2 times 24, I'm going to do the top line and do the bottom. And when you're multiplying fractions, you just do it like that. You go, so you'll get 2 times 24 is 48. 3 times 1 is 3. And so that's how you do that first one. Now, if you wanted to write it as a mixed number, you'd say, how many times does 3 go into 48? And so if you see that, you'll see that 3 goes into 48 16 times exactly, and the final answer is just going to be 16.
So?
Yeah.
So what if it's not 16 exactly?
Then you would have a little piece left over. So say, for example, if you had 47 over 3, you would then have 15 and 2/3. Because 15 times 3 is 45, and you have 2 left over. We'll do that a little bit later. For now, I want to practice just the multiplication.
So,
Yeah.
can I also just jump in here? Just
Yeah.
for number 1 and 2, there's also a short route that I would like to explain to the learners.
Oh, absolutely.
But it doesn't always work. So I want you guys to quickly look at number 1. So there it says 23. I meant 2 over 3 or 2/3 of 24. Now the short route is to take the whole number, which is 24, right? And then we divide it with the bottom of the fraction. So in other words, I'm not putting it over as a fraction of 1. Okay? Now, we know that 24 divided by 3 is 8, if I'm not mistaken.
Yep.
Take that answer times by 2, we get 16. Now, for number 1, that route will work. But now let's try and do that for number 2. Can I actually say 18 divided by 5? Can I do that? No, I'll have a remainder.
Yeah.
So the short route that I showed you now can only work if your denominator can divide into the whole number. If not, then you'll have to go to Sir's route, where you first change, in this case, number to 18 as a fraction, and any number can be written as a fraction when it's over 1.
Yeah.
So that's just something I wanted to add there.
No, it's very useful. And you will see us using that more and more as you get comfortable with fractions. And it is a useful trick. But the main idea I want students to focus on is, if you're multiplying a fraction by a number, it's really helpful to put that number over 1. It just makes life so much simpler if you do that. Now, in the case of 2, you're right, 5 doesn't go into 18 exactly. So we have to then go, what's 2 times 18? It's 36. What's 5 times 1? It's 5. Now, this is where the question I was saying, 5 doesn't go into 36 exactly. So we say, how many times does 5 go in? Well, 5, 10, 15, 20, 25, 30, 35. It goes 7 times, but I only get to 35. So I'm 1 short, and I get 7 1/5. So the main idea is that. So we say top with top and bottom with bottom. We sometimes have to write a number over 1, and then we also have to practice the skill of converting between improper and proper. I want to give a little bit more time for the next one, though. Etlechang, Kayalichle has got an answer coming in. I'll give a little bit more time before I move on. Karabo, your hand is up. Can I answer your question?
Karabo, you're on mute.
Okay, maybe it was just a kind of a hand that went up just in case. So we get 6 over 15. And if we want to, that's right. The answer is right. But what happens is 6 over 15 has what we call common factors, or there's a 3 hiding in both 6 and 15. So if we divide 6 by 3, we get 2. And if we divide 15 by 3, we get 5. And so both of these would be equivalent fractions. They're both correct, but that would be considered the most simple. And whenever a number has a common fraction, or a common factor, divide it out like that. I think most people got 6 over 15, which is great from what I can see of the answers. And it is a good idea to simplify where at all possible. And then for number 4, 3 times 2 is 6. 7 times 5 is 35. Now, is there any number, I want to follow up with Ms. Anya, is there, 6 over 35 is fairly straightforward, but is there any number which is hiding inside of 6 and 35? So I think that if we go back to the very first method of the 6 could be written as 2 times 3, that's its prime factors, and 35 could be written as 5 times 7. I don't see anything which can be cancelled out here. because 5 doesn't go into 3, 7 doesn't go into 2. And so we cannot actually simplify those any further. There are no hiding common factors. If we don't cross multiply, will we lose marks and tests? Okay, careful with the word cross multiply. When you're multiplying the top with the top and the bottom with the bottom. That's when you multiply fractions. Be very careful. Multiplying fractions is very simple. Top with top, bottom with bottom. If there is no bottom, say for example, like 2/5 times 18, then we give it a bottom by making it 18/1. And I think it's important we get that idea, we practice it nicely today. I think I'm going to make up another one for you. I feel like we're not quite there yet.
So can I just jump in here with Una? Una, when we cross multiply, like Sir is saying, we're just multiplying the top and bottom and bottom. We're not really touching cross multiplication yet. I think, because I know Una's mentioned in the chat that they've done it at school before. So try not to get confused with that, with what we're doing now. This is just another method. Remember, there's more than one way to approach maths. There's multiple ways to solve a problem. So I hope that answers your question.
I want to see, can everybody do number 5? I've made up a question for you now. Can you multiply 7/9 times 5/6? And I just want to see, can you carry out that multiplication? That's all. Just to kind of see. And again, when you're multiplying two fractions, and basically today is about the method that we were confirming from the last lesson, adding and subtracting fractions, and now we're doing multiplying fractions. Yeah, Micah, I think you're on the money. 7 times 5 is 35. What is 9 times 6? Scarlett, I think you have got it.
54.
That's it. Perfect. Okay, so in some ways, I feel like multiplying fractions is actually easier than adding them. Because when you add and subtract fractions, they have to have the same family name. But when you are multiplying two fractions, notice how you have a 9 and you have a 6. They don't have to have the same family name. So in some ways, the rules are a bit more relaxed with multiplying. And I think that helps everyone a lot. You just make sure that you separate the two ideas.
And then, so just something as well that I would like you to provide clarity on the class. It's been asked 2 or 3 times in the chat.
Yes.
Students are unsure, like, should they always simplify or should they not? Do you mind just sharing your 2 cents regarding that?
So normally as a math teacher, equivalent fractions are equivalent, right? So there's nothing wrong with writing. The example I think that people have is 6/15 is the same as 2/5. If your teacher specifically says, leave in the most simplified form, then it's possible that you could lose a mark if you don't get to the final thing. But if they don't say, leave in the most simplified form, there's nothing different between 6/15 and 2/5. They are the same number. Now, if you want to see if you can simplify a fraction, all you're going to be looking for is there a number that divides in the top and divides in the bottom? So for example, 2/4, I can divide the top by 2 and I get 1, and I divide the bottom by 2 and I get 2. But if I try and go further than that, I can't really keep on dividing smaller pieces unless I get to like a fraction. So for me, I wouldn't worry too much if your teacher specifically says, because the thing is, if you get a weird thing like 6/35, you don't want to spend 5 minutes checking and then eventually you figure out, oh, there's nothing hiding in there. So the one thing you can do is you can write the numbers as their prime factors, but I feel like that's overkill, because you're kind of going to such, I would say, simplify it if you can, but more stress than that is just not worth it, in my opinion.
Okay, thank you, sir.
Now I want to talk a little bit about division, like the older brother of multiplication. And I don't know if I'm squeezing too much, if I should wait till the next lesson for division. No, I think we can do it. Okay. This first question, 3 divided by 1/4. If you try and imagine what does it mean to divide 3 by 1/4, conceptually or as an idea, it's a bit weird. Like, how do you divide something into pieces of pieces? It's a little bit weird. So what we need is a process or a way of understanding how to calculate this that makes sense to us. So I just want to quickly do something on the side here. If I said to you, what is 3 times 4 equal to? Could you answer me in the chat? What is 3 times 4? I want to see everybody put that in the chat. Okay, you guys are winning at life, right? So it's 12, no problem. Okay. If I said to you, I want to now divide by 4. What's 3 times 4 divided by 4?
3.
Yeah, it's 3. Now, how do we know that? Well, we know it because timesing by 4 and dividing by 4 are inverse processes, opposite processes. They undo. Basically, if you start with something and you multiply it by 4 and divide it by 4, you end up where you started. Okay? I think most of us kind of know that. Like, there are these processes that are, if something does something, the opposite undoes it. But now I want to show you something more interesting. If I say to you 3 times 4 times a quarter, okay, what is that going to be equal to? Now remember, we've just learned about multiplication. What is the answer for 3 times 4 times a quarter? Anyone?
Okay. So just to help you guys, so 3 times 4 is 12, and then 12 times a quarter. So you're going to say 12 over 1,
Yeah.
right? Times 4 over 1, which will give you 12 over 4. And then you need to simplify that, and then you get
3. Okay. Yes, you got this. Okay, now let me point this out. This may not seem obvious, but if you take away the beginning and the end, we've got to the same answer each time. Both of these, we said if we gave it a 3 to start with, and we did this, we ended up with a 3 at the end. And what I want to show you is that dividing by 4 or dividing by 4 over 1, because remember, 4 can be written as 4 over 1. If you divide by 4 over 1, it is exactly the same. So if I think of this, divided by 4 over 1, it's the same as multiplying by 1 over 4. So when I started this, the whole reason I wanted to show you this was you all told me that you knew that if you started with 3 and did this stuff, you got back to 3. All I want to do is show you that dividing by 4 over 1 is the same as multiplying by 1 over 4. That's it. Now, if we believe that is the case, how can we use this in this question over here? We call it a reciprocal relationship. So let's think about it. If we think of this question, 3 divided by a quarter, we are going to say 3 over 1 divided by 1 over 4. And what we showed in the previous bit of the lesson was if we want to change from a division to a multiplication, all I need to do, what do I need to do to the 1 over 4? If you put it in the chat, what am I going to multiply by in the second bit? What did we do earlier on?
Multiply.
Multiply by?
1 times by 4.
Okay, so what we're going to do is we're going to multiply by the opposite. So we do one little change and we make it 4 over 1. So that's the only trick with division. If you want to change, if you're going to do a division question, we normally change it into an equivalent operation, which has multiplication. But when we multiply, we switch the top and the bottom around. And that's what I was trying to show you a little bit earlier. Now, once you've switched that around, you know how to multiply 2 fractions. 3 times 4 is 12. 1 times 1 is 1. So you switch those things around. So I'm going to do the second one with you as well, just to kind of illustrate this process again.
So
yeah.
Sorry to interrupt you.
Oh,
I asked in the chat if the learners or students are familiar with the KFC method. Are you familiar with the KFC method, sir?
I'm not familiar with the KFC method.
Yes, ma'am.
It's something that's very easy of these. Do you mind if I run through number 2 of them like that?
Guys, I just realized it's 5 to 6. We've actually
Yes.
gone over our time. Flip. Guys, we're going to have to, I'm going to start the next lesson. I'm going to start the next lesson with this, but I've just realized I have to get off now.
That's fine, sir.
Anya, if you could put the link in the chat. I got so into my fraction there. Guys, in the next lesson, we will talk about division separately. So I just want you to pause if you're unsure, but I really do want everyone to go into the quiz now and just do your best with the quiz and just so we get a feel of what you know. But we'll talk about KFC in the next lesson. Thank you so much, Anya, for your help. I'm going to go across to the other lesson. But I look forward to seeing everybody on Monday. Bye, guys. Sorry about the sudden